as promised, in this video, we're going to be talking about the actual forces that exist in the universe and that cause an object's motion to change. Okay? And to kick this off, I want you to actually ask yourself a question. Pause the video and write down as many forces as you can think of. All the forces that you've ever heard of, ever, in the universe, or that you can think of, or that you can imagine, right? Write them all down on a list. Now. Okay. Hopefully you've unpaused. Now, some of you, maybe you couldn't think of too many. That's fine. Some of you, maybe you have a huge list of all these different forces. Everything from, all UFC guys like hitting each other, to gravity, to, maybe electric force, to normal force, to centripetal force, right? There's all these different forces, Coriolis force, all these different forces that we've ever talked about or heard about in the news and in media, right? But I'm here to tell you, if you could advance to the next slide that says 4 fundamental forces, I'm here to tell you that there's really only 4 forces that exist in the universe, and all the other forces that we talk about are some manifestation of these 4, okay? And I'll explain what I mean in a second, okay? So it turns out there are 4 fundamental forces, just 4. They are, so I'm going to put this 4 fundamental forces. They are 1, gravity. Gravity is a fundamental force. There is 2, electromagnetic. Okay. There's 3, the strong nuclear force. And then there's 4, the weak force. Okay. And go ahead, look at the pictures on this slide and see if you can match which of these belong to each of these pictures. And I will now go ahead and explain, first of all, what it means that an object is, what it means that a force is a fundamental force. Okay. What that means is that there's actually a subatomic particle, right? Some kind of fundamental particle that's responsible for that force. All right. For gravity is the force that we all understand and know, right, in the universe, right? It's what binds galaxies together, which is what binds solar systems together. It's what draws the hydrogen together to form a star. It's what pulls the hydrogen so hot and squeezed right into this little tiny chunk of ball that fusion actually starts, causing all this energy to be released, which is why suns are so hot and they're so bright and they provide all the energy that, for example, our planet needs. And so that's gravity. Okay, gravity is basically the glue of the universe. It binds the universe together. Okay, then you have the electromagnetic force, right? And this is obviously responsible for everything from static electricity effects to lightning to how we are able to power these cities and how you're able to get power on your computer right now. This is the force that happens between any 2 charged particles. Okay, when those 2 charged particles have opposite charges, there's an attraction. When those charged particles have like charges, they repel each other. Okay, there is strong nuclear, which is responsible for what actually binds nuclei together. And there's this very interesting anecdote, which is that in high school, the first thing anyone teaches you in like a chemistry class is that like charges repel. And then the second thing they tell you in chemistry class is that atoms are made of these nuclei that are made up of all these little protons, right? And yet, it just goes to show you there's something really silly about modern education where no kid raises their hand and says, wait a second, you just told me likes repel, and then you told me that there's this nucleus where there's all these like particles, all these protons together, stuck together. How does that make any sense? Well, if you did ask that question, your chemistry teacher, if they were knowledgeable, would say the reason is strong nuclear force, right? Because strong nuclear force is the strongest of the fundamental forces, and the way it works is that it operates at a very short distance. So if I have two protons, right, okay, and I'm bringing them together, getting closer. They're like, no, I don't like it, I don't like being near you, I don't like it, no, okay. But then when they get at a close enough distance to each other, right, when they're just close enough where the strong nuclear force is stronger than the electromagnetic force, then suddenly they're like, oh, I like this. This is really nice. And they get all cozy and sit together inside of the nucleus together, okay? And then lastly, weak force is the one you'll see the least in an intro physics class like this, because it's simply responsible for certain kinds of radioactive, specifically beta decay, okay? Now, that begs the question. You're like, Scott, I don't understand this. What about all these other forces, right? When I sit down in a chair, I don't fall through the ground, right? What is that force pushing me back up? Well, it's a very interesting question. As I said, every other force that you see in the world or that you experience is somehow the result of these four fundamental forces, right? So what about the force that is keeping you from falling through the earth when you're sitting down in your chair? Okay, what is that force that's pushing up on your butt such that you are in equilibrium, you are balanced, right? Okay, well, what is your butt made of? Atoms. What is your chair made of? Atoms. What's on the outside of all atoms? Electrons. So you have this situation where your butt is down here, your chair is here, and there's these electron clouds coating both. What do they do? What do those electrons do? Those electron clouds do? They repel, right? So in other words, your butt and the chair are repelling each other, right? In fact, the repelling is so great when you get close, right, that you're not actually even touching, right? Your body is picking up signals that make you think you're touching, right? But you're actually not. You're kind of just kind of hovering there, right? So that means two things. That the force that's keeping me from falling through the floor and you from falling through the floor is just a version of the electromagnetic force, right? It's a manifestation of the electromagnetic force. And the other implication of that is that you, my friends, have never touched anything. You've never hugged a loved one. You've never kissed your beloved. And that's a little bit sad. It makes us a little bit more lonely. I'm getting really sad now as I'm doing this lecture. But there's, I guess, a bright side, right? Because you also aren't really responsible for anything. So, if I were to just steal this pen, did I really steal it? I never even touched it. All right, think about it. Okay, so that's fundamental forces. And I'm just going to say, if you guys could advance to the next slide, I'm going to say this is kind of like an extension of what I've been saying, but there are these other special forces. So what about things like friction, centripetal force, and weight, right? Well, weight is a manifestation of gravity, right? And I'll just go ahead and say weight is equal to mass, your mass, times the gravitational field you're in, right? In our case, that's just 9.8. So weight is a manifestation of gravity. Friction is, just this roughness of two surfaces, right? So let's say that there's one surface like this, and then one surface like this. This one's going this way, this one's going this way, okay? And again, it's two surfaces in contact, electrons on the outside, electron clouds on the outside. Those clouds are interacting. Friction is also a manifestation of the electromagnetic force, okay? What about centripetal forces? We're going to talk more about that next week, but centripetal forces can be caused by many different forces, right? Usually electromagnetic, but we'll get more into that in a bit. And then the normal force that we're talking about, right? So there's this little bug here, right? This little bug is hovering on water, right? Normal force means that force that's always pushing up on you from a surface, okay? That too is a manifestation of the electromagnetic force. And And then obviously there's tension, right? What if I am just hanging from like a branch from a tree or something like that, right? I am just a fellow who's swinging on a just terrible draw, Scott, just terrible. I'm swinging on a branch, right? And so there's a tension holding me up so that I don't fall on my butt, right? That tension too is a manifestation of electromagnetic forces. Okay. Basically, every force you've ever heard of always just comes down to one of these four fundamental forces. Okay. In the next video, we're going to be talking about how to represent these forces in pictures. It's something called a free body diagram, and they are so important, and you're going to resist doing them. But I've been doing physics for like 400 years, and I still draw free body diagrams for every problem that I do in forces. It just makes your life so much easier. So I'm going to teach you how to do that in the next video, and get in the good habit of every time you're doing a force problem, you draw a free body diagram. Even if you're doing any kind of problem, draw a free body diagram, which is just a picture that shows the full collection of forces that are acting on any given object. Okay? See you there.